this question, unique paths in a grid. So the question basically says that we have a matrix grid of n cross m size, and it will have two values, zeros and 1. So a value of 1 means that we can go to that particular cell, and 0 implies that the cell we cannot go to allowed there. So we will start at the 1 1 of the upper left corner, which means this first, or you can say 0 0, and you have to reach the bottom right corner nm, which means to the end, such that you can only move in the right or down direction. Like we can go from this one to the second one, that's one, and or we can go from that one to the down one. And also according to the condition that we cannot go into this 0 because this is blocked. So now we have to find the total number of ways such that we can reach from this first 1 1 or 0 0, you can say, to this nm, or we can say to the last element, following the condition that we cannot go to any 0, or we have to travel only right or downward. And we have to make sure that the answer should be modulo of 10 to the power 9 plus 7. So let's begin by defining the modulo. Like we'll take long int, okay, modulo, and its value should be 10 to the power 9. Let's make sure we have that number of zeros. 1 2 3 4 5 6 7 8 9. Actually here our 7 will go. So that's right, I think we have it correct. So we have defined the mod, right? And okay, so now what we can do, we can at every step, let's say we have the 1 and 1, and similarly we have the 1 and 1. So from here we can go to this one or this one. So at every stage what we can do, we can travel from the first position to the rightward or to the downward. So we will make a different function where we will be keeping our current position. Okay, so can find unique paths. Okay, so it will have int current I and current j, int n, int m, so that we keep the size of the grid. And we'll also pass the grid. We'll pass it by reference because we are not going to change it anything here, and we'll be needing and it shouldn't take the extra space. So this is what we are doing now, and we will be returning in the unique paths from the current I and current j at every step. Also we can pass the long int, or we can define it in because this is not needed, I think. So we can just define this value. I can take it from here into this. Okay, so now we are at the current I and current j. So from here we can go to right or to downwards. So first the first thing that we will check that if we are at the n and m, let's say we are at the last stage, so that we can check like current I is equal to n minus 1, because we are keeping a 0 index, n or okay, and current j is equal to m minus 1. So if this is the case, then we will simply return 1, means like we have reached here. Okay, now for going to right, so if current I is smaller than n minus 1, it means that we are not at the last row, and grid current I, if we are not at the last row, this will check if we are at the last row, and if we are not at the last row, then we will check if the next if the element in the next row on the same column, if it is 1 or not, right? If it is 1, then we can easily proceed there. So then we will proceed there, and we will then find we'll then go to that row and we will increase our I value to +1. Like now we have reached there and other things will be same. So n and m and grade. Okay, so we can go there. What we can do here is that this is we can say that this is one of the ways from where we have reached there. Okay, so we can take the value that, okay, from here we have how many paths. So we'll answer that, we'll take that value, that paths. Okay, in paths, in path count, we can say from current I and current j we have how many path count. So that we can increase that path count we can increase by taking, like, from the next step how much path do we have. So if we have any number of paths, so we will just add it into our path count. Okay, similarly we will do the same thing for our, I think why it's not getting copied. Okay, now for the column part, so we'll compare j with we'll make sure that we are not at the last column, and if we are not at the last column, then the next element in the next column on the same row should be 1. If it's not 1, then we cannot go there, and we will add that into the path count. Okay, and we will be returning the path count from here. Now this should give us the answer, right? Okay, what we can do, we can also okay, we can return the path count modulo mod. Okay, because that's now been increased, and actually this value could go larger. Okay, so okay, we're going to take it, and also, like, as this is this function will also be returning something like this path count dot mod, so this will also come in the form of mod only, so we don't have to worry that the value will be so much big that it will already be corrupted. So that won't be the case. At max it will be greater than this 2 into mod. It will always be less than the 2 into this mod value, because every step we are doing the modulus from this value. Okay, so this would give us the path, but one thing is there that we would be traversing the same path a lot of the time. Like we could go, let's say if we have 3 size array. Okay, then in that case we would be going like from the first to go there, and the other way we will go there, and from here also we will reach at this point, and from this side we will also from second row we will also traverse to the side column, and from the first row we will go into the second column. So in the both way we will be traversing the second element on the second element at the second row and the second column like 2 times. So what will happen that most of the time the value will be redundant, and we will be calculating each time from here. So why don't we keep this value saved, that so that even if we travel multiple times through the same path, we have the same, if we have already calculated the value from there, so we just store it. So what we should do, we should take a DP grid. Okay, so what I'm going to do is I'm going to define DP value of the long and like of the each value. Okay, sorry, DP. So that's it, and so this will be our DP. So what we'll do, we'll first populate it with a value, say -1. Okay, so we'll start, and we'll first travel to the n. We'll first fill the row, and what we'll do that at every step we'll be defining a row. Okay, and and we will be appending it into the post back this row. Okay, now what we need to do that now for every row we need to add a value into its column. Okay, so for what we'll do for j starting from 0 up till 2 m-1, what we will do, we will be just for the current I, as now we have defined we have pushed value into the dp, so it's a dpi, and into that we can now push back as -1. Okay, so this is how our dp get defined, and what we will do, we will pass this dp into this into our find unique paths function. So the dp grid will also get passed there, and as you can see we have the dp grid there, and what we will do that at every step, like we'll let me pass through them here, otherwise it starts showing error. Okay, so what we will do for every current I and current j, we will be getting this value path count mod. Okay, and we'll just simply be returning this dp value. Okay, so that is our value, and so now we are storing the value in the dp, so we'll also be checking the value in the dp. Okay, so if we have the value stored in the dp, okay, let's say if the dp, if we have already traversed this, so the value won't be -1, because initially we have initialized it with the value -1, so it shouldn't be -1. So if it is got updated, then it shouldn't be -1, otherwise we will go and do all the process. So if it's not -1, then we can simply return this dp value. Okay, so this is how we have got the dp, and now we'll be calling this function. Okay, so we'll start with 0 0, means the first row, first column, and then m value will be same, grid will be same, and dp will be same. Okay, so and we can just simply return it, because it will already be, I think, done modulus by modulo. So let's see what value we get. So let's now, okay, run it and see if it comes correct. Okay, it's giving compilation error at some point of time. So and we are comparing the grid value. Actually there is definitely some mistake is going on. Okay, right, so actually it is a 2-dimensional array, so yeah, I have to I should have mentioned the column as well, and in this case row here as well. Let's see if any new error comes, and we are getting the segmentation fault. Okay, let's see what is in the segmentation fault we are getting. Where could have gone wrong, and yeah, I think, yeah, okay, when we just copied it, okay, yeah, when I just copied it, actually, yeah, I forget to change row from the column. Let's see if it will work now. Okay, it is working. Let's try to submit, see if it's coming it in the time or not. So okay, no, multiple test cases. Okay, input is too large, output difference, and my, okay, it is saying the value should be 0, and my code output is this much, so this must be some modulus error. So I will have to check that. think okay, in this case what is the problem is that I think the first element itself is 0 and we have not handled that case because we are handling the 0 case outside means before calling the function only. So okay, we can add this condition here, like even if we don't in that case, even if we don't mark a check here, like if it's not 1, like we can remove this condition. So I think that will also work, but we can do what, like we can check if the current element is 0. If the current element is 0, we can simply return 0 from here, that there is no path from here at all. So you can just go back, and I think it should work now. Let's see if any new error come. Okay, I think it's correct. Okay, so thank you. That is all. Was this its whole solution? So this is the entire solution, that what we have done, that we have defined the mod, we have checked if the last element, then we will return the 1, and we'll check if the current grid is 0, then from here we will just return the 0. And other than that, like even if the last element is let's say even if the last element is 0, so we don't need to worry about that, because those cases are being handled here, that before going to the last element we will just check if that if the upcoming element on which we are going is 1 or not. If it's not 1, then path count won't be incremented and it will remain 0, and in that case, like all we will get is a 0 at the end. So what we do here is that we check, and then we check if the element has already been traversed in DP, and then we'll check if the next element is 1 or not, in the next row element is 1 or not, if the next column element is 1 or not. If the 1, then we go there and we simply go there, and then we update the value in DP, and then we return the value. And here we have already we have initialized the DP with the value of -1. So this is the code. Thank you.